Now we are going to see how we can apply all the properties. Let's say first we have gamma of 13 upon 3. N is our 13 upon 3. So we know that gamma of n is nothing but n minus 1 into gamma of n. So here n is 13 by 3. So 13 by 3 minus 1 into gamma of 13 by 3 minus 1. So 13 by 3 minus 1 is nothing but 10 upon 3, and this will be gamma of 10 upon 3. Again here we are going to apply the same property. Now the n becomes 10 upon 3, that is 10 upon 3 minus 1 into gamma of 10 upon 3 minus 1. So 10 upon 3 into this will be 7 upon 3 into gamma of 7 upon 3. Again for 7 upon 3 we can apply the same property. So 10 upon 3, 7 upon 3, 7 minus 3 will be 4 upon 3 into gamma of 4 upon 3 equal to 10 upon 3 into 7 upon 3 into 4 upon 3. Gamma of 4 upon 3 will be 4 minus 3, that is 1 upon 3 into gamma of 1 upon 3. So this is how we use to simplify our fractions. Then we have gamma of 9 upon 2. Similarly, what we are going to do, we are going to keep the denominator as it is, as you can see here. So and we are going to subtract 9 minus 2. 9 minus 2 is 7 upon 2. 9 minus 2 is 7 upon 2, and denominator remain the same. Then we subtract 7 and 2, that is 5, denominator remain the same. Then we subtract 5 and 2, that is 3, denominator remain the same. Then we subtract 3 and 2, which is half, denominator remain the same. Then after this we are left with gamma of half. The last term will be gamma of this term, and gamma of half, we know that gamma of half is root pi. So this is how you can solve the problem of gamma function. Third, we have gamma of 10. What is gamma of 10? We know that when we have a positive integer, gamma of n is nothing but n minus 1 factorial. So gamma of 10 will be 9 factorial. What is gamma of 2? Gamma of 2 is 1, we have calculated. Then we have gamma of 7. What is gamma of 7? It can be a 6 factorial. Gamma of 7 can also be, we know that the property of gamma of n is nothing but gamma of n plus 1 upon n. So it will be gamma of 8 upon 7. In this way we can also solve this problem. What is gamma of minus half? For negative integers we are going to apply this property. So gamma of minus half will be minus half plus 1 upon minus half. So this will be minus half goes in the numerator, it will become minus 2, and gamma of 1 minus half is nothing but gamma of half, which is minus 2, and gamma of half is root pi. So you can remember minus gamma of half is nothing but minus 2 root pi. So in this we have positive integers and we have all the fractions which are in which our n is greater than 1. Now we have case when n is between 0 and 1. In this case, when n is between 0 and 1, then gamma of n into gamma of 1 minus n is nothing but pi upon sine n pi. This is a result of our equation. We can prove this equation. So when our n is between 0 and 1, then gamma of n into gamma of 1 minus n is nothing but pi upon sine of n pi. Let's take an example. We have gamma of 3 by 4 into gamma of 1 by 4. Then if you see, if we consider n equal to 1 by 4, then 1 minus n will be 1 minus 1 by 4, which is 3 by 4. So these terms are matching. So the final solution will be pi upon sine of n into pi. N is 1 upon 4. What is sine of pi by 4? Sine of pi by 4 is 1 upon root 2. So when root 2 goes in the numerator, it will be root 2 into pi. So this is how we can prove all the properties of gamma. This will be more clear when we see the problem on gamma function. So the problem on gamma function we will see in our next video. So stay tuned for our future lectures.